Hi everybody. In this video we will learn about atomic structure, what is atom, and what what are the different subatomic particles of atom. Earlier on we learned about the history of the atom a little bit, and now we will talk about actually in your class we only talked about atom. We have not talked about the history yet. But anyway, let's talk about atomic structure. Atomic structure is the structure of the atom, as it says. It talks about the subatomic particles. Okay, so we need to learn about protons, electrons, and neutrons. As you know, this is the center of the atom, so it is the nucleus, and these are the energy levels around the nucleus. So electrons are traveling in these discrete spaces. So either electron is here or here or here. So this is kind of the planetary model that we call it. So this is how atom looks like. So in the center of the atom, which is called nucleus, we have protons and neutrons, and electrons are the ones that travel around the nucleus. Number of proton is the positively charged particle, okay, and the mass of the proton is 1 AMU, 1 atomic mass unit, and the location of the proton is nucleus. So this is the charge, this is the mass, and this is the location. So this is how we need to know about the three particles. Electrons are negative in charge. Okay, the mass of the electron is 1/1836, which is almost 0, and the location of the electron is around the nucleus. Neutrons have no charge. Okay, they are neutral. They are present inside the nucleus, and their mass is 1 AMU, and they're present inside the nucleus. So these are the three subatomic particles you need to know. So usually, I'm sure you already know what electron, proton, and neutrons are, but when the question says subatomic particles, you kind of get confused with it. So you must understand that when we say subatomic, it means protons, electrons, and neutrons. There are much more particles that we know today but that are part of the atom, but in this course we will only talk about the three basic subatomic particles that are protons, electrons, and neutrons. You need to know their location, where are they located, you need to know what is their mass and what are their charges. Now, number of proton is the identity of the element. Okay, number of proton is the identity of the element. If we change the number of proton, we change the element. Atomic number is also known as number of protons. Okay, atomic number is the number of protons. When you look at the periodic table, you will see two numbers like this. So this number is the atomic number. Okay, this number is atomic number or the number of protons. But please do not get this concept that I'm telling you that the bottom number is the atomic number and the top number is atomic mass. There could be a periodic table that you will see like this. Okay, it depends which periodic table you have. So not necessarily it is top or bottom number. The smaller number is the atomic number or the number of protons, because it is only the number of protons. This number is a larger number because this is protons and neutrons together. So this is the atomic mass. All right, the atomic mass is coming from the nucleus. It is mass of the nucleus, and inside the nucleus we have protons and neutrons together. That's why the mass of the nucleus is twice as much as of the protons and neutrons. Again, as I said, that atomic number is the number of protons only, and this is the identity of the element. Keep it in mind. If you need to ever identify the element from the periodic table, you only look at the atomic number, because atomic mass can change. Now you will also find that atomic mass could be in decimals, like for aluminum it could be 26.9997 kind of thing, and I'm rounding it to 27. So atomic, because it is the average mass of all the isotopes present. So what I'm giving you 27 here is actually the mass number. So speaking of aluminum, if aluminum is exactly, let me tell you, 26 30.98354, then the mass number will be 27. So mass number is the whole number. Okay, mass number is the whole number or the rounded number of the atomic mass. So keep it in mind that we need to know these three terms. Atomic number is the number of protons, which is right here. Atomic mass is the average mass of all the isotopes, which will be in decimals. Okay, so this is the atomic mass, and the mass number is the whole number of that atomic mass. So if this is the atomic mass, this is the whole number. When we calculate the number of neutrons, we must use the mass number, okay, and subtract the atomic number out of this. The number of neutrons can never be in decimals. What I mean is that, let's say I ask you to calculate the number of protons, electrons, and neutrons for aluminum. So let's write it again, that you have aluminum. Aluminum is 1327. So let's calculate the number of protons, electrons, and neutrons for aluminum. Atomic number is the number of protons. Okay, so it has 13 protons. If it has 13 protons, it must have 13 electrons, because protons are positive, electrons are negative. They both have to be equal to get the atom neutral. This aluminum has no charge on it. That means it is neutral. So if it is neutral, it has equal positive or negative. So to calculate the neutrons are present inside the nucleus. I just explained that earlier on. And inside the nucleus, you have protons and neutrons together. Okay, so what I'm going to do is I'm going to take my mass number, okay, and minus the atomic number. So the mass number is 27 minus 13, it will be 14. So I have 14 neutrons. Okay, so keep it in mind, this is how we do it for any element. So let's say I have phosphorus and 15, and the atomic mass for phosphorus is like 30.97376. This is the atomic mass, not the mass number. Okay, for the mass number it will be 15, and I will say 31. No, it is the mass number. Please understand the difference between atomic mass and mass number. Okay, so to calculate the protons, electrons, and neutrons, I will be using the mass number. So I have 15 protons, because 15 is the atomic number, and it will have 15 electrons. So this number gives you the both electrons and protons, because protons are positive, electrons are negative. To get the neutrons, I will do 31 minus 15, so it will be 16 neutrons. You must have a whole number for neutrons. Neutrons cannot be in decimals. So let's talk about this. Let's talk about carbon. So you have so if atomic number is 15, atomic number is 5, that means you can identify the element. That you can go to the periodic table and find out who is the element 5, who has 5 protons. So if you go to the periodic table, you will find out that boron has 5 protons. So if you have 5 protons, it will have 5 electrons, because protons and electrons have to be the same. Now to get the neutrons, I will do mass number minus the atomic number. So mass number is 10, atomic number is 5, because I have 5 protons, that means its atomic number is 5. So a 10 minus 5, will give you 5 neutrons. So to calculate the number of neutrons, that means you can write this on your paper, that to calculate the neutrons, you will do mass number minus atomic number. This is how you calculate the neutrons. So you have mass number right here, atomic number right here. So 10 minus 5 will give you 5. 12 minus 6 will give you 6. And atomic number and number of protons is going to be the same, because this is the identity of the element. And number of protons and electrons is going to be the same, because this is positive, this is negative. So this one number is going to be the same for all three. Atomic number is the number of protons, which should be equal to the number of electrons. So all these three numbers are going to be the same. And mass number is given right here. And now you go to the periodic table, identify the element only by the atomic number or the number of protons, not by the mass number. And when you go there, you will find out that this is the symbol of boron. Okay, So that's all you need to learn in this, and so go ahead and complete this page and then move on. So you can pause the video right here and complete the page before you move on. Let's the next topic we want to talk about is this is a little bit more practice. I was already giving you the example of aluminum. Aluminum has 13 protons. 13 protons means 13 electrons because they both have to be equal to get the atom neutral, and then 14 neutrons. And again, how do you have 14 neutrons? Because you have 27 minus 13, which gives you 14 neutrons. Atomic number is going to be number of protons, which is 13, and mass number is going to be the combination of atomic, you know, number of protons and neutrons. So to calculate the mass number, you will be adding protons and neutrons together. If you add protons and neutrons together, that gives you the mass number. So add protons and neutrons together to get the mass number. So I hope you have enough understanding of how to calculate electrons, protons, and neutrons. Let's talk about the history of the atom. So you need to make a foldable for this. It's called the history of the atom foldable. You're supposed to take the 3 sheets of paper, plain sheets of paper, and put them on top of each other, leaving some space, and fold it in a way that it gives you 6 flaps. So it gives you 1, 2, 3, 4, 5, and 6 flaps, and then fold it in the middle. You can write the title on the top, this history of the atom, then fold it in the middle in a way so that you can have different scientists on the sides. You don't really need to memorize the year, but you can talk about the scientist. So let's get going from here. Alright, so please take your time to go ahead and complete the get the paper ready. You need 3 plain sheets of paper, and then you fold them to make 6 flaps, and then you fold them in the middle. Ask me in the class if you need help on this. Once you have, you can pause the video here and write these names. And once you completed it, let's move on. So Democritus was the first ever scientist who ever gave us the concept of atom. He used the Latin word atomos. Atomos means indivisible, means something you cannot break any further down. Okay, so that was the Latin word for atomos. And from where he got the word atom, because when he gave us the concept of atom, he said atom is the smallest particle, that we cannot break it any further down. Although today we know that we can break the atom, but at that time when Democritus gave us the concept, he said we cannot break it any further down. And he said everything is made of atoms. So he said everything in the matter, everything is matter, solid, liquid, and gas. And he said everything is made of atoms. But he could not really give us any proofs of this. He just gave us the concept. But it was very important because it made everybody think on the lines of that atom. Although there were different scientists that came later on, like Aristotle, who did not really agree with Democritus. But as the time passed on, there were many other scientists who did agree with him. So, but anyway, you need to memorize that Democritus was the first ever scientist who gave us the concept of atom, who said that matter is made of atom. The next scientist is Dalton. So Dalton was the first ever scientist who gave us the first ever atomic theory. Okay, so the first atomic theory was given by Dalton in 1803. According to the points of atomic theory, the postulates of atomic theory, all matter is made of atoms. All atoms are indestructible, means you cannot break it any further down. Chemical reactions rearrange the atoms but cannot lose them. So it is kind of law of conservation of mass. So he said when you have a chemical reaction, you kind of break the existing bonds and you make the new bonds. But in that process, you cannot lose anything. You cannot gain anything. So it was very important concept. So though you have to memorize the 3 points of Dalton, The Dalton gave us the first atomic theory. According to his theory, all matter is made of atoms. Atoms are indestructible and indivisible. And chemical reactions, you don't lose or gain any atoms, you only rearrange them. And he gave us a first atomic model. It's called solid sphere model. So he didn't know anything else about the atom, like no protons, electrons, or neutrons. He said that atom is like small circles, small balls. Billiard balls is also a name of the Dalton's atomic model, billiard ball model, model, or solid sphere model. But because he didn't know anything about electrons, protons, and neutrons at that time. So you need to know Dalton, you need to know the 3 points of Dalton, you need to know that Dalton gave us the solid sphere model. The next scientist is Mendeleev. Mendeleev was the first ever scientist who gave us the periodic table. We call him father of the periodic table. Okay, father of periodic table, because he was the first scientist who ever printed a periodic table. Every people could hold it. There were many scientists before him who started putting the elements together in the form of groups, but in the form of groups of 3 elements together, 8 elements together. But he was the very first one who arranged the elements by their mass, and he said if we arrange them by the mass, we see a trend in the properties. And based on his periodic table, he left some empty spaces, and he predicted that these elements exist. Because the time that he printed the periodic table, or he put together the periodic table, there were only 62 elements that were known, and today we know about 118 elements. So he did mention, and he left spaces in the periodic table, like he will leave some space here, 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 and he will say that these elements exist, that scientists will find out later on. So it was a very important step in the history of science, or I should say chemistry. Um, I should have gone to from Dalton. Dalton gave us the solid sphere model. He knew nothing about the atom. And after Dalton came the Thomson. Okay, his name actually was J.J. Thomson. J.J. Thomson did a glass tube experiment. He took a glass tube, he filled the tube with the gas, okay, very lightweight gas. There were 2 electrodes, one positive, one negative. Okay, the negative one is called cathode, the other one is called anode. And when he plugged it in, he saw that small particles came out of the cathode, and they were attracted towards the positive plate. Okay, and he had magnetic field around it to calculate the charge of those particles. So since those particles were coming out of the negative plate and they were attracted towards the positive plate, he named them electrons. So this was the first ever scientist who went inside the atom, who saw what's inside the atom. So first subatomic particle. So same kind of experiment was used to calculate to find out protons. But Thomson is known to discover electrons, and he calculated not really the charge of electrons, but he said that electrons are negative. So you need to know the J.J. Thomson is a scientist. He did the cathode ray tube experiment. Okay, you need to know the name of the experiment. And in this experiment, he discovered electrons. So it was a glass tube filled with very light gas, and you have opposite plates, and he discovered electrons out of this. So the model that he gave us is called chocolate chip cookie model or plum pudding model. You will see both these on the tests or quizzes, because he said it looks like a pudding which has positive and negative charges spread all over the place. So it's a plum pudding model. All he knew at that time was protons and electrons. So he said it's a sea of positively charged particles in which electrons are kind of spread all over the place. So 2 scientists have told you by now in reference to atom. One is Dalton, one is J.J. Thomson. So Dalton did the solid sphere model. J.J. Thomson did the plum pudding model. Okay, so you have to know these 2 models. This is solid sphere model, and this is the plum pudding model. Next comes the Rutherford. So Rutherford knew that there is a plum pudding model. You know, it's positive, negative, all over the place. So what he did is he took a gold foil, like a aluminum foil, you know, just like aluminum foil, a thin sheet of gold like that. So he took that thin sheet of gold and he surrounded it with the fluorescent screen and he threw alpha particles on it. So here is the alpha particles. Alpha particles are positively charged particles. So when he threw the positively charged particles, he was expecting that most of them will come back because he knew the plum pudding model, that this is all positive and equal charges repel each other, right? So if I'm throwing positive particles on this, I expect that they will all come back. But when Rutherford took this gold foil, you know, as thin as aluminum or maybe thinner than that, of course it has atoms of gold in it, right? So, and he's expecting that atom of gold look like this because that's what the J.J. Thomson has told him. So he took this and he found out that most of the particles went straight through. Okay, instead of sticking to it or instead of coming back, they went straight through. So if the positive particles are going straight through, that means there is no positive, otherwise they would have come back. There is no negative, otherwise they would have stick to it. So the very first thing he ever said, that most of the atom is empty space. That is why most of my particles went straight through. It was like 1 out of 100 that came back, maybe 2 out of 100 that were kind of deflected. So he said most of the atom is empty space, but there is a center of the atom that is a positive charge because it is very little chance that you will hit that center. So most of my particles are going straight through. There is very little chance that you will hit that center and then you go back. So it was very little chance to hit that center, that the particle that came back. So most of the atom is empty space and there is a center, a short positively charged, some particles repelled because they hit the positive nucleus. So he was the first one who gave us the name of the nucleus. Okay, so he created a nuclear model. So according to his nuclear model, there is a nucleus and he is the one who said protons and neutrons are inside the nucleus and electrons are around the nucleus. So now we have solid sphere model, then we have plum pudding model. So it is solid sphere model, and then we have plum pudding or chocolate chip cookie model. Okay, and that plum pudding and chocolate chip cookie has electrons all over the place. Okay, and then from there we go to the nuclear model. So you must understand these scientists. The Rutherford did the gold foil experiment and he said most of the atom is empty space and he gave us the nuclear model. You know, he gave us the nuclear model. The next model is, the next scientist was Moseley. Moseley discovered protons before, of course, this model, and he arranged the periodic table by the atomic number. So as far as the history of the periodic table is concerned, Mendeleev was the one who arranged the periodic table by atomic mass. Okay, keep it in mind. And then after Mendeleev came the Moseley, who arranged the periodic table by the atomic number. Okay, so no arranged by the atomic. So the one that we use today is arranged by Moseley, which is arranged by atomic number. So now comes after Rutherford comes Bohr. So we have three models by now, as you see: solid sphere, plum pudding, nuclear charge. Nuclear model, and then comes the Bohr, who said that instead of just having a sea of electrons around it, the electrons follow a specific path around the nucleus, and just like orbits follow a specific path around the sun. So that's why we call it a planetary model. Okay, just like um, uh, planets orbit around the sun, he said electrons orbit around the nucleus. So we call it a planetary model. And he said the orbit that is close to the nucleus has less energy, and as we go further away from the nucleus, they have more energy. So we call them orbits. And as I'm saying, the orbit closer to the nucleus has less energy, and as we go further away from the nucleus, it has more energy. Chadwick was another scientist. He discovered neutrons. So you need to understand that Chadwick discovered neutrons. So overall, these are the models that we need to learn. We have solid sphere model, and Dalton gave us the solid sphere model. We have chocolate chip cookie or plum pudding model, and who gave us this one? J.J. Thompson. So J.J. Thompson gave us a plum pudding model. We have nuclear model, and who gave us this one? Rutherford. And then we have Bohr's model. So we have different energy levels, and this one has low energy, this one has high energy. So we have planetary model given by Bohr. And the latest model that we know today is the quantum mechanical model. Okay, the current model today is the quantum mechanical model that says that we have nucleus in the center, and then around it is just like a cloud. There is no there are no defined orbitals. Like it's not like Bohr. It's not like one, two, or three. It's just like a cloud, like a running fan. When a fan is running, all you see is the center of the fan, and then you see a cloud around it. You don't really see the wings of the fan. Same thing is the quantum mechanical model, that all we see is a cloud around the nucleus. We cannot really define the lines there, according to Bohr's explanation. So these are the models that you need to know about the atom. You need to know the history of the atom. You need to know the history of the periodic table. Um, all these notes that I have given you, they go underneath the scientist. So you are supposed to pick up the flap of each scientist and write the notes underneath it. So let me know if you have any questions. Thank you, everybody. See you later. Bye.